Okay, good morning. So let us continue to talk about the fundamental queuing system. Before we have the fundamental queuing system, we need to directly have the concept Markov process. Therefore, we directly have the definition Markov process here. All right, so for all of you, you can look at this Markov process and check in the definition. And let me pass the standing badge to, the standing badge of the group to each group. So you still follow the original seats. So, and Jen over there. Okay, so Markov process actually it depends on the current state rather than the previous states. So for example, here we have all of these, and then we can change based on the current state. Only the present state. All right, so then we can have the state transition diagram like this. So we want to apply Markov process later to help us to analyze the system. So this is the Markov process. And one specific process, actually it's a Markov process, but we call it birth and death process. So that it's a special type of Markov process. And why we want to use it? If we have some size, specifically population. All right, for example, number of jobs in queue. Currently, we want to consider this. Number of jobs in queue to have the analysis. All right. And why we have both? For example, previously, or maybe later, we have the state transition diagram. We can directly know, oh, we have one direction. The direction bring the birth. And another direction bring death. That says we can increase so that we have the direction of birth. And we will decrease and so that we have the direction of death. And we can pass on the two directions so that we have the Markov process, and this kind of Markov process we call birth-death process. Well, in fact, we have the spatial Markov process. But right now, Markov process, we already have the rate. So we have the direction to represent birth. And here the state means the population size. All right, and this direction is death. And we have the corresponding state. So from 0, then we have lambda sub 0, and 1, then we have lambda sub 1. And the death, we have the corresponding index 1 because of the current state, population size. And this is the state transition diagram of a birth-death process, but we already know, oh, okay, it's continuous birth-death process. Continuous means we have the index continuous time, so that we call it the continuous birth-death process. But Should we include continuous here? Actually, later we will have, if we just try to have a different way to check, perhaps we don't call this continuous birth test process. So currently, let me simply call we have the birth test process. And this birth test process, we can have the state transition diagram. Then we will pass on the state transition diagram to help us have the performance measures. But to have that one, we will pass on that. So right now we have Markov chain. Oh, sorry, Markov process. Or maybe we should call chain. In fact, right now, because of a process, so it should be continuous. And if it is discrete time one, we should call Markov chain. But in fact, sometimes it should be Markov chain. So I already have a Markov chain as well to birth test. And then right now, we want to have MM1. So we just follow the track and so that we will formally apply some technique to have the performance measure for the process MM1 because we want to that you have the traffic theory and that you have a system. And this system serving as an example. Well, so MM1 based on the previous can-down notation. So M, we should have the exponential inter-arrival time, and service time follows the exponential time as well. So one, we have a single server. Even we don't have the fourth and fifth positions, actually we have MM1 infinity. So we have the size, the buffer size should be infinite size. All right. For this kind of a system, actually we allow a customer to arrive. And it will be served only when the server is free or is idle. Or otherwise, the customer need to line up in the queue. So it will be queued. And currently, we don't have the specific description about the service discipline. So we have the simple one, first in, first out. You just come and we're in order. So this is the first in, first out. And we have the actual assumption. We have independent, identically distributed. So IID. Independent, identically distributed random variable for inter-arrival times because of person, so of course it should be IID. But right now we enforce it, inter-arrival times are IID so that we have the person process. And likewise for service time, they follow IID random variables as well. All right, so here we try to emphasize we have the possible feature of all the system of MM1. So this patch actually that all of you to understand we have a system. This system based on the can-down notation. We have MM1. And how to have the real operation, this one. We have a queue and we have a server, a single server. We have a customer. And once finished service, then depart. All right, so this is the really, maybe not basic, but at least really simple queuing system. So we already have this one because we still can have the extended one, but we started from this one, MM1. And likewise, we emphasize MM1, skip this. So this one skip, but we emphasize explicitly. Don't forget, we have the size. The size is infinite size. So infinite size here. Well, maybe something wrong. So previously, we should have the rate change, but we have This rate change here, so something wrong, but let me continue. Well, for this MM1, so currently actually we pass on MM1. And we start from birth test process into the current one. Birth test process we mentioned, we should have the rate depends on this. Depends on this, but look at this. No. So that says 0, 2, the others equal to lambda. Likewise, mu 0, it should be mu 1. So the others equal to mu. Therefore, MM1 is a special case of a birth test process. So we have the special case directly. And for the special case, we will have the derivation for the performance measure. Well, about this, maybe let me ask you this first. About the current system MM1, and later we will have the analysis for this MM1. About the MM1 here, any questions? In fact, I don't have the poll, but I ask you directly, so any questions? If yes, raise your hand and let me know. No, right? So, let me go to the next one. It's an activity, attendance checking, but something wrong, so let me refresh it. Okay, so this is attendance checking today, and you can scan the QR code and join. And sometimes something wrong, so I need to refresh it so that we can have this. Go and check it. So you can continue. So you never signed this, right? About recording. And later pass it to me. So anyone else failed to fill in this form? Consent to record. Finish, right? Okay. You finish it? And how about Jen? About the form here? Okay. No, I mean this form. You finish it? Consent to record. So you can sign, you can check it and sign for me. And how about you? You got it and finish it? Same for you? Finish it? Okay, thank you. All right, so if it is okay, let me go to the next one.